3-5, Equations of Lines in the Coordinate Plane, Part 1. Alright, here's your vocab. I know it's kind of a different format for the vocab this time, but I wanted to go ahead and give you a diagram so I can go ahead and explain some of these. So, first word is slope. The slope, which is represented by m of a line, is the ratio of the vertical change, known as the rise, to the horizontal change, known as the run, between any 2 points. So if you look here, we have a line, and it says a line contains points x1, y1. Now what that means by x1, y1 is, say this, so this is point 1, 2, 3, comma 1. The 3 would be x sub 1, and the y would be y sub 1. So anywhere you see an x sub 1, you'd put in a 3, and anywhere you see y sub 1, you'd put in a 1. And this point here is, let's see, 3, 4, 5, 1, 2, 3, 5, 3. So anywhere you see an x2, you're going to put a 5, and a y2, you're going to put a 3. All right? So m equals rise over run, which is y2 minus y1, so in this case 3 minus 1, over x2 minus x1, which is 5 minus 3. Alright, so this would be 2 over 2, which equals 1, so this line has a slope of 1. Alright, next word is slope-intercept form. The slope-intercept form of an equation of a non-vertical line, that's the key word, non-vertical, line is y equals mx plus b, where m is the slope and b is the y-intercept. So this is your slope right here, m, meaning if we were writing the equation for this line, m would be a 1 because it has a slope of 1. And the y-intercept is where it physically crosses the x-axis. This is all you need to draw a line, is the slope and the y-intercept. That's all you need to draw a line. So if you know that the y-intercept is, say, -2 with a slope of 1, you can just simply draw your graph, go down to y equals -2, and then the slope of 1 is, for every 1 it goes up, it goes over 1. So up 1 over 1, up 1 over 1, and then you have 3 points there that you could easily draw your line through. All right, so you only need 3 points to draw a line. I mean, sorry, you only need 2 points to draw a line, and if you have your y-intercept, you have 1 point, and then your slope, you can find another. Next is point-slope form. The point-slope form of an equation of a non-vertical line is y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is a point on the line. So for instance, we could write the equation of this line with y minus y1, so we're using this as x1, y1. We can go y minus 1 equals m, our slope was 1, times x minus x1, which is 3. Now, if you notice, the y1 and the x1 we replaced with numbers, but this y and this x will always remain in this equation. You will not get rid of them. They are equivalent to this y and this x in the slope-intercept form equation. In fact, we can solve this down. I'm not going to do it right now, but we can solve this down and actually get it to y equals mx plus b form. So this y, this first y, and this first x will always remain in this equation. They're not going to go anywhere. All right, so make sure you got these words written down, because you're going to need to know what these are, because I will ask you, use point slope form and do this, and you're going to need to know what it is. So make sure you remember these. All right, now there's 4 different types of slopes. You have a positive slope, which points upward and to the right. Okay. You have a negative slope, which points down to the right. You have a slope of 0, which is a horizontal line. And then you have an undefined slope, which is a vertical line. An easy way to keep track of the 0 slope and the undefined slope is just think of like a tennis ball. You could put a tennis ball on here and it would, I mean, this is perfectly flat so it wouldn't roll, but it would hold the tennis ball. Here, you can put a tennis ball and it would roll down here, hill. Here, you can put a tennis ball and also roll downhill. But here, you couldn't roll a tennis ball on a straight line. Because, I mean, you could set it against the wall, but it may fall away from the wall or something. All right, so an undefined slope, you can't roll a tennis ball on. All right, so that's one way to remember that it's an undefined slope. Plus, the actual equation for this, say you pick 2 points, all right, well, since they both have the same x value, you're going to be dividing by 0. All right, so that's another way you're going to know it's an undefined slope. All right, but there's 4 different types of slopes, and you need to be able to recognize them on sight as well. So up and to the right is positive, down and to the right is negative, completely flat like this is a 0 slope, or some people say it has no slope. That's the same thing, or no slope. And then here we have a vertical line which has an undefined slope. Now, undefined and no slope are different. No slope is the same thing as 0 slope. Undefined slope, it physically does not have one. All right. So what is the slope of line B? Here's line B. So what we're going to do is we are going to use our slope formula. So m equals y2 minus y1 over x2 minus x1. Now, it's important to remember that it is y over x. It's rise over run. It is important to remember that. So now, what we're going to do here is we're going to assign one of these to be 0.1 and one of these to be 0.2. So I'm going to make this 2 and this 1. So we're just going to do m equals y2, which is negative 2, minus y1, which is 2, over x2, which is 4, minus x1, which is negative 1. So this is going to be a positive 1. So negative 2 minus 2, negative 4. 4 plus 1 is 5. So our line B here has a slope of negative 4/5. All right. Now, we need to figure out the slope of line D. And again, you can use your slope formula, or if you remember from before, a vertical line has an undefined slope. So the slope of this line is undefined, or undef, as I abbreviate it. Because if you physically did this, if we called this point 2 and this point 1, you're going to have 0 plus 2, because it's minus negative 2, over 4 minus 4. So you're going to have 2 over 0, which of course is undefined. So that is why a vertical line has an undefined slope. All right. So what I want you to do here is I want you to find the slopes of line A and C. So pause the video for a couple seconds and figure those out. All right, so line A is right here. All right, let's call this point 2 and this point 1. And I just picked these at random. I mean, you could make this 2 and this 1, doesn't matter. All right, so our slope is m equals y2 minus y1 over x2 minus x1. Oops, forgot my negative. So y2 is 7 minus 3 over 5 minus 2. 7 minus 3 is 4. 5 minus 2 is 3. So the slope of line A is 4/3. Now, you're not going to want to reduce this or change it to a decimal or anything. You're going to want to leave it as the fraction 4/3. A slope of 1 1/3 doesn't mean as much as a slope of 4/3 does. Or a slope of 1.3 repeating really doesn't tell you anything either. So you'll want to leave this as the improper fraction 4/3. All right. And then C, since C is a horizontal line, it is said to have no slope or a 0 slope. Because again, if you do this, the y2 minus y1, if we make that point 2 and that point 1, we're going to have 7 minus 7 over 5 minus 1, which is 0 over 4, which is 0. So it has 0 slope or a no slope. That's supposed to be or a no slope. All right. What is the graph of y equals 2x, 2/3 x plus 1? It says the equation is in slope-intercept form, y equals mx plus b. The slope m is 2/3 and the y-intercept b is 1. So that's your slope, that's your y-intercept. So remember earlier I said you can graph your y-intercept and then just use 2/3 to use your slope to get your other point. So we're graphing our y-intercept of 1, so you simply stay on your y-axis and just go up 1 and put a point. So you plot that point. Then what you do, since slope is rise over run, you can simply count up 2 spaces, 1, 2, and over 3 spaces, 1, 2, 3, plot you a second point, and then connect the line between them. All right, just like they explain here. So you only need 1 point because the y-intercept, you know that your x value is 0. So you only need 1 point and your slope to graph a line. All right, again, you just plot your y-intercept, y equals positive 1, count up 2 over 3, boom, you found your second point. All right. Now, what about this? This is in point slope form. It says y minus 3 equals negative 2x plus 3. It says this equation is in point slope form, y minus y1 equals m times x minus x1, and the slope is negative 2, and the point x1, y1 on the line is negative 3, 3. But this is a positive 3. So why do they got a negative 3 here for x? Well, if you remember, this is x minus x1. So since this is a positive 3, that means this is x minus negative 3. All right, x minus negative 3. And this is y minus y1. So this would have to be y minus a positive 3. Easy way to remember this is when you bring these points down to put them in your parentheses to actually use the point, flip the sign on them. This is y minus 3, so you know your y1 is going to be a positive 3. Since this is x plus 3, you know your x1 is going to be a negative 3. It's important to remember that. Okay, it's important to remember that since this is y minus y1, this looks like it's a negative 3, but in reality it's a positive 3, and this is x minus x1, so it looks like a positive 3, but it's really a negative 3. But if you just remember to change your signs when you bring the numbers to put them in your parentheses, that can help too. And we know the slope is negative 2. Well, if you remember, all whole numbers can be written over 1, so it's really a slope of negative 2 over 1. So what we would do is we would plot the point negative 3, 3. So 1, 2, 3, 1, 2, 3. Plot that point right there like they did. Then, since this is negative, you go down and to the right, whereas on the last one we went up and to the right. All right. As long as you always go to the right, and then for a negative slope you go down, and for a positive slope you go up, you'll always get it right. All right. Plus, remember how I said you need to be able to recognize positive and negative slopes on sight, because if you're like the slope is negative and you accidentally went, say, down and to the left, connected it, then you'd have a positive slope because it would go up to the right. But as long as you can recognize that, you'd be like, what did I do? I got a positive slope. It should be negative. And then you can look at it and go, oh, well, I went to the right where I should have. I went to the left where I should have went to the right. So, so this is down to 1, 2, and over 1 to plot your second point here at negative 2, 1. And then you just draw your line between them. All right. So it's important to make sure that you either go up and to the right or down and to the right. As long as you always move in the horizontal direction, as long as you always move to the right, positive you go up, negative you go down, you should be all right plotting your points using your slope and actually getting the correct slope. All right. So here's your ticket in the door. What I want you to do is and I gave you 2 graphs because I know some people screenshot this and print it out. Or if you don't, maybe you should on this one because I'm giving you the graphs. Or you can use graph paper, or you can hand draw a graph. Just be a little neat with it. Any way you want to do it's fine. But I want you to graph the line y equals 3x minus 4. Graph that one over here. Make this graph A if you're printing this out. And then make this graph B over here. And then also I want you to graph that line and graph y minus 2 equals negative 1/3 x minus 4. All right. Make sure you have this ready when you come in the room tomorrow. Feel free to look back through the slides if you want to, or back through your notes because you should have written most of it down. So good luck. See you tomorrow.